Hi, thank you for taking the C# Advanced course. My name is Mosh Hamedani and I'm going to be your personal instructor in this course. In this course, I'm going to take your C# skills to the advanced level. I'm going to teach you the language features that you need to know in building real-world applications. Whether you want to build mobile apps, desktop apps, or web applications, you're going to be using these features all the time. Features like LINQ, Lambda expressions, events, delegates, extension methods, nullable types, generics, exception handling, and so on. I hope you enjoy watching this course, and let's get started. Okay, that's the part that I hate to talk about because in my culture, we are taught to be modest and not to talk about ourselves. But you, as my student, might want to know who your instructor is and whether they're qualified to teach the course you have taken. So here is my story. I started programming at the age of 7 with the Commodore 64 and totally fell in love with it. Since then, I continued learning more and more about programming. So I've dedicated pretty much most of my life in learning and practicing programming. In my high school years, I was more of a C and C++ programmer. And later, in 2002, when .NET version 1 was released, I shifted to C# and .NET platform entirely. So I have 12 years of experience designing and developing applications with C#, and at the time of recording this, I'm also a full-time C# developer. I'm also a Microsoft Certified Technology Specialist, Application Developer, and Professional. In terms of my educational background, I have a Bachelor of Science in Software Engineering and a Master of Science in Network Systems. Recently, I started my YouTube channel called Programming with Mosh. So if you'd like to learn more, subscribe to my channel. Now you're wondering, Mosh, do you have a life outside programming? Of course I do. When I'm not programming, I'm playing jazz piano, doing Latin dancing, or photography, as well as cooking. I love cooking. Okay, that's it about me, and I will see you in the next lecture. Okay, before we move on to the next section, I want to spend a couple of minutes and talk about something very important. I want to make sure I've set the expectation right before you get started. So please watch this video to the very end. I've done my best to produce this course with all the materials you need. But as you work through the course, there are times that you might have questions. Here we have a discussion board where you can post your questions. But remember, this discussion board is mainly for students to help each other, not as a medium for me to answer every student's questions. Because even though I would love to help each of you individually, unfortunately, that's not possible. Because given the volume of students I have on Udemy and the subscribers on my YouTube channel, it's really hard to answer everyone's questions. And believe it or not, this gets more challenging every single day. I'm sure you would feel the same if you were in my shoes. Remember, just like you, I'm a regular person and I have limited time per day. If I answer everyone's questions, I have to literally stop producing new content. And I'm sure that's not what you want. I've got several thousand students who are constantly emailing me and asking for new content. Mosh, can you do a course on this? Can you write a blog post on that? So I just want to set the right expectation. I will answer your questions when I get a chance, but this is more of a nice thing to have, and it's not something you should expect as part of this course. Because what you have paid for is purely for the material, proper structure that leads you from zero to hero, so you don't have to jump from one tutorial to another. Plus the exercises that I have carefully designed to ensure the best learning experience for you. That's what you're paying for. And this is not a private one-on-one class. And I want to make sure we're on the same page before you get started. Now you may say, but Mosh, there are other instructors who are very active in the discussion board and they answer every single question. I don't know what they are doing, how many courses and students they have, but maybe they have superhuman power. Unfortunately, I don't have. Now, all that aside, if you have questions, remember a lot of times you can get your answer much faster if you just simply Google it. I've seen a lot of questions on the discussion board that have an answer on the first page of Google. Also, in particular, I do not answer questions that are about some code not working on your machine or you're getting a runtime error. Because if you want to be a real coder, you need to troubleshoot these issues yourself. You cannot expect others to fix the compile time or runtime issues with your code. So I do not answer these questions whatsoever, purely to help you become more independent and better at solving these problems on your own, so you can be successful in your career. All right, that's all I wanted to talk about. I hope you're on the same page. Now let's move on to the next section. Hi guys, my name is Mosh Hamadani, and in this video I'm going to talk about C# generics. Before we start with generics, let me explain what problem generics came to solve. In .NET version 1, we didn't have generics. So let's say we wanted to create a list to store a list of numbers. This is a simple and basic implementation of a list. We could have a method called add to add a number to the list, and an indexer that returns the number at the given index. Now, of course, there are more methods like remove and find, and I'm just leaving that for simplicity here because the intention is to talk about generics and not data structures. Now, if you wanted to store books in a list, obviously this class wouldn't work. So we had to go and create a class like this. Call it book list with a method called add, a parameter called book, and similar indexer. Now the problem here is for every type we have to create a separate list. And this is a lot of code duplication and not productive. Plus, if there is a bug, we have to fix it in multiple places. So one solution to fix this is to use a list of objects, something like this. With the object, because the object is the parent class for every type in .NET, we can easily pass any types to this method here or get any object from this indexer. But there is another problem here. The problem is performance. If we use this class for storing value types like integers, every time we insert a value type inside this list, it has to be boxed to be stored as an object. And every time we access that value, it has to be unboxed. And this has a performance penalty. Or even if you use reference types, every time we want to cast an object, let's say a book, to an object or vice versa, this casting again has performance penalty. So generics came as a solution to resolve this problem. With generics, we create a class once and reuse it multiple times. And it doesn't have the performance penalty like with the object list here. So let's see how we can create a generic list. Let me get rid of this code here. So I'm going to create my generic list next to this one so you can see the differences. We start with public class. I call it generic list. Now, generics have a parameter, and the parameters are specified with angle brackets. So like this. And we usually call them T, as in short for template or type. Now we create our add method. Now, instead of getting a book here, we would get a T. What is T? We don't know yet. The consumer of this class will specify that. I will show you in a second. Similarly, to get the object at the given index, we return T. So that's all we have to do. Now let's see how we can use that. We go to our program CS. So here, we're instantiating a book object. We're instantiating a list of numbers, as you see, and we're instantiating a list of books. Note that the problem here is that we have two different types of lists. We can simply use our generic list instead of these two classes here. So I can actually comment out this piece of code. Now let's create a list of numbers. I use the generic list. And here I specify the type of T that we specified earlier. So in this case, we want a list of integers. So I'll put int here. And now when I access the add method, note that the parameter is of type integer. We can use the same generic list to store a list of books. So I specify book as the template parameter. And say books.add. Now the add method gets an object of type book. So new book, blah, blah, blah. So see, we get code reusability and we don't have that performance penalty. Why? At runtime, our generic list is actually a list of books. It's not a list of objects. So there is no casting or boxing. So this is the basics of creating a generic list. Now, in practical terms, most often you will be using generics as opposed to creating ones. In fact, I personally, in my professional career as a .NET developer, have very rarely come across situations that I had to create generic classes or generic methods. I would say maybe 3 or 4 times over the course of a few years. Most often, you will be using the generic lists that are actually part of .NET. So you're not going to create a generic list. In fact, let me show you where all the generic collections are in .NET. So you go to system.collections.generic, and look, here we've got a bunch of classes like dictionary, hash set, some interfaces like iCollection, iDictionary, iEnumerable, which is pretty popular, iList, linked list, list, which is like our generic list, queue, sorted list, stack, and so on. But in case you need to create a generic for the application you're working on, the rest of this video I'm going to cover more details about creating generics. So let's get back to our generic here. See, here t is a parameter. We could have multiple parameters. For example, a use case of that is for dictionaries. A dictionary is a data structure that uses a hash table to store and retrieve objects, which provides a very fast and efficient way to access objects. So with a dictionary, we need to specify a key and a value, and they can be of any type. So let me create a dictionary here. Public class generic dictionary. So I want a key here and a value. Note that I'm prefixing them with t and giving a proper name here, like this is the template parameter for key and this is the template parameter for value. I have seen some developers use something like t, u, or v here, which actually makes no sense in terms of code readability. So always prefix your generic parameters with t and then give it a proper name. So in this case, our dictionary has 2 parameters, t key and t value. Our add method would look something like this. T key, key, t value, value. Now, to use that, we can go back to our program CS. Let me create a dictionary here. Generic dictionary. I want my keys to be of type, say, string, and values can be of type book. This way, I can call the add method, and note that the first parameter is a string, and the second is a book. So I can say 1, 2, 3, 4, and I'm going to store this book here. Just like that. Another thing you need to know about generics is constraints. Look, in this case, our generic list here, or generic dictionary, any type can be passed here. There's no limitation. Sometimes this is good, like in terms of list, you probably want to store a list of anything and everything, so there is no need to apply constraint. But sometimes you would want to limit what is being sent here. Let me walk you through some examples. So back to our program CS here. And we use ReSharper to put it in a separate file. Okay. Let's say we would like to create a method that gets 2 parameters, let's say 2 numbers, and returns the bigger one. So typically, this is how we do it. So if A is bigger than B, we return A, otherwise we return B. Now, if you want to create a generic version of that, this is how we do it. So public, instead of returning int, we return t, and the name of the method. Here we add the template parameter. And of course, both of our parameters are going to be of type t. So ta and tb. Now, see, if I write the exact same code, it's not going to work. Why? Because at this time, the compiler doesn't know the type of t. So it cannot apply comparison between A and B. At this point, it thinks A and B are both objects. Let me show you that. So these are the methods that are available in A, which come from the object class. So what we need to do here is we want to assume that both A and B implement a comparable interface, which provides a method called compareTo. And with that, we can compare these two objects. So that's a use case where we need to apply a constraint. We apply a constraint by going here at the end of the method and saying where t, we use colon, as in is I comparable. With that, if I say a dot, see, we get a new method here, compareTo, which comes from a comparable. So with that, we can say if A compareTo B is greater than 0, return A, otherwise return B. Also note that here I created a generic method inside a non-generic class, and that's perfectly fine. So you don't always have to start with the generic class. We could potentially move this template here to the class level. So utilities for T, where T is iComparable. And then we don't have to repeat that here. We can just get rid of that. Just like that. Okay, now that you have an understanding of constraints and why we need them, let me show you the other types of constraints. Here are 5 types of constraints. You can say where T is iComparable, as in applying a constraint to an interface, or you can apply a constraint to a class. In this case, we are saying if T is a product or any of its children, any of its subclasses, you can say T should be a value type. So we use the keyword struct. Or you could say where T is a class, as in it has to be a reference type. Or you can say where T is an object that has a default constructor. Now, don't worry, I'm going to walk you through these with examples. So far you have seen a constraint to an interface. Let's take a look at a constraint to a class. So I create a new class here, public class, say discount calculator T product, where T product is a product. Now I'm going to move this to a separate file. So in that case, I can create a method here. Let's call it calculate discount, which gets a parameter of type product or any of its subclasses. And here, look, we get the price and title attribute or property. Earlier, I created this product class. Let me show you. So this is my product class. We have a title and a price. We also have a book class here that derives from the product and adds an extra property here called ISBN. So with that constraint, when we say T product should be a product or any of its subclasses, we have access to all of its properties or methods here. Now, we don't really care about the actual calculation of the discount, but you got the point. Let's see an example of a constraint to a value type. So a public class nullable T, where T is a value type. Let me move that to a separate file. Okay, what is this used for? Well, in C#, as you know, value types cannot be null. So an integer should have a value like 0, 1, 2, 3. It cannot be null. We can use this class to give our value types the ability to be nullable. So let's create a constructor here. Let's say in the constructor we can get a value, and in this class I'm going to store it as an object because I want it to be nullable. So private object value, and here let me initialize it with resharper. We can press Alt and Enter here, and Enter. And it automatically initializes my private field with the value passed in the constructor. Now I want this class to have a property called hasValue. So if my object has a value, it returns true. Otherwise, if it's null, it returns false. Get return. So if value is not null, return true. And we can have a method called public, which returns t, get value or default. So with this method, if our object is initialized, let's say we have a number that is set to 5, it returns the value, which is 5. Otherwise, it returns the default value for that type. So for integers, it's 0. So what we need to do is we say if it has value, then return value. Now we just have to cast it because this value here is of type object, right? But this cast is perfectly fine and it's safe because that's what we are passing here in the constructor. We're storing it here. It's basically being boxed to be stored in the object, but here we are unboxing it and that's perfectly fine. Now, what if it's not set? What if it's null? We need to find the default value for that type. How do we do that? We use the default operator. So we say return default of t. So default is a good keyword that you need to know. Now with this class, what we can do is we can go ahead and actually, I forgot to create a default constructor here in case the value is not set. Now let's go to our program CS and use that. I'm going to clear everything here. We don't need them anymore. So I can say for number equals new nullable of int, I can give it a value like 5. Let's log something to console. So CW, it's a code snippet. Press tab. I would say hasValue plus number that has value, console write line, and the actual value is plus number that get value or default. Let's run this code. So note that, yes, it has a value and its value is set to 5. Now we can use this class without setting a value. In this case, we have a nullable integer. So let's run this again. So it has a value? No. What is the default value? It's 0. Now, you don't really have to go and create this nullable class. It's actually part of .NET Framework. You can find it in system.nullable. It's defined here. And in fact, it's a structure. Look at this icon here. It's not a class. So let's go here. So this nullable is using a constraint to specify that t has to be a value type. Let's look at another example. Let's go to our utilities class here. Let me create another method here. Public void do something with t. Now let's say in some specific scenarios we want to instantiate an instance of t. So if you want to create an object, you want to do something like that. But that doesn't work because at this time the compiler doesn't know exactly what type t is referring to. All it knows is that t should implement a comparable interface. If you want to instantiate t here, you need a default constructor, right? So what you can do is to apply a second constraint here. You can separate constraints with a comma. So to have a constraint to a default constructor, that's what you use. New. Now this is perfectly fine. So with constraints, we can specify that t must implement a given interface or be of a given type or any of its subclasses, or be a value type or a reference type, or have a default constructor. I hope you enjoyed this video and thank you for watching. So what is a delegate? A delegate is an object that knows how to call a method or a group of methods. A simpler way to define that is a delegate is a reference or a pointer to a function. Now, why do we need something like that? We can call methods directly. Why do we need a delegate that is responsible for calling methods for us? Well, this technique allows us to create applications that are extensible and flexible. And often this is used in designing frameworks. Let me explain this in code. Here in this project, I have a class of photo that represents a photo or an image. A photo processor, which has one method called process. It takes a path to a file, loads the photo, applies a set of filters like brightness, contrast, and resizes the photo. Let's take a look at the photo filters. For simplicity, I have just used console.writeLine because we don't want to get distracted with image processing algorithms here. But the point here is, imagine you're responsible for designing a framework that is used for processing photos. This code has a problem. It's not extensible. What do I mean by that? Well, look, so far we have applied 3 filters here. What if you release this framework, but another developer wants to use your framework and apply a new filter that you haven't defined? Then the problem is you have to create that filter and recompile and redeploy your code. Now imagine if every time a developer in the world needs a filter, you have to keep compiling and deploying your code. And this is not a good idea. So with delegates, we can make this framework extensible such that a developer can create their own filters without relying on you. The same problem can be solved by interfaces using some kind of polymorphism. But in this video, I'm going to show you how to use delegates to achieve this. Later, I will give you a simple guideline to choose whether to use delegates or interfaces. So before we change anything in this code, let's run the application and see what happens. So we got 3 messages on the console, applying brightness, contrast, and resizing photo. How do we use a delegate to make this extensible? First, we need to define a delegate type. So we start with public delegate. When defining delegates, we need to define the signature of the method that this delegate will be responsible for calling. So let's say void, and I'm going to call it photo filter handler. It takes a parameter of type photo, and that's it. So this is the name of our delegate, and an instance of that delegate can hold a pointer to a function or a group of functions that have the signature. So they're void and take a parameter of type photo. Now to make this method extensible, instead of hard coding these filters here, I'm going to get rid of that and pass a delegate to this method. And call it here, passing our photo object. What this means is this code does not know what filter will be applied, and it's the responsibility of the client of this code. Whoever is using that, they will define the filters they want. Maybe a developer wants to apply only brightness and contrast. Maybe another developer wants to apply 10 other filters. It's up to them. This framework does not have to be recompiled and redeployed, which makes it extensible. Now, the client of this class is our program.cs. And imagine this is the code that you as a developer or a consumer of that framework is writing. So here, first, we have our photo processor instantiated. Now, let's create an instance of that delegate. So our delegate is photo processor. I defined it in that class, and it's called photo filter handler. So filter handler equals, I'm going to point it to a method. What method? Well, we can start with this photo filters. Let's assume that this was released with the framework. So let's say we want that delegate to point to this method first. I create an instance of photo filters. Filters equals new photo filters. Right? Now my handler, which is a delegate or a pointer to a method, is going to point to filters.applyBrightness. And in our process method, we pass this filter handler here. So now if I execute this code, let's see what happens. We get apply brightness. We can easily change this code and apply another filter. So we get the delegate here and we use the plus equal operator to add another filter or another pointer. Filters.apply contrast. Let's run the application again. Look, now we got two filters. And what is interesting is that if I need a filter that was not released with the framework, I can create my own here. Let's say I would like to create a filter for removing red eye. Static void remove red eye filter. It takes a parameter of photo. So this method should confirm with the signature we defined here for our delegate. So again, a delegate is a pointer to a method with the signature. Back in our program. So this is my custom filter. And here I'm going to type in console.writeLine, apply, remove red eye. I can go ahead here and add that to our delegate to remove red eye filter. Let's run the application. There you go. We got the new filter here. So delegates are very powerful and allows us to create applications or frameworks that are extensible and very flexible. Again, you saw that I added this new filter here, but that class, the photo processor, was absolutely unchanged. So was the photo filters that were released with the framework. Now let's get back to our program. I want to show you what happens under the hood when we create a delegate. So I'm going to put a breakpoint here with F9 and press F5 to run the application in the debug mode. Okay, let's inspect this filter handler variable. Look, it derives from multicast delegate class. So every delegate in .NET that we create with the delegate keyword is essentially a class that derives from multicast delegate. Let's expand that. So that class, multicast delegate, is derived from system.delegate. Let's expand this. This delegate class has two public properties, a method and a target. Method represents the method that the delegate is pointing to. So in this case, we set our delegate to point to apply brightness method of photo filters class. So target is the class that holds that method. Now, let's continue execution one line. So F10. Let's see what happens. Filter handler. I expand it here. Because it derives from multicast delegate, that means we can have pointers to many functions, which in this case, we have two functions or two methods, apply brightness and apply contrast. Let's take a look. So if I expand multicast delegate in the non-public members, it has a field called invocation list. Let's expand that. So it has two methods. One is apply brightness, one is apply contrast. So the difference between multicast delegate here and delegate is that multicast delegate allows us to have multiple function pointers, whereas delegate allows us to have only one function pointer. So in this case, because we are appending multiple filters, multiple function pointers to our delegate is a multicast delegate. Okay, let me stop the debugger. Okay, now you have an understanding of what delegates are and what we can do with them. Let's go back to our photo processor code here. See here we defined a custom delegate that points to a method that returns void and takes a parameter of type photo. Instead of creating our custom delegate, we could use one of the existing delegates that come in .NET Framework. In .NET, we have two delegates that are generic, and they are action and func. Let me show you how they work. System.action, So action, as you see from the icon here, is a delegate. It comes in two forms. One is non-generic and one is generic. Let's look at this one. Look, it has 16 overloads. One that takes only one parameter. Here is another one that takes 2 parameters, 3 parameters, and up to 16 parameters. So this action can point to a method that takes any of these parameters, a method that takes 1 parameter or up to 16 parameters. We have another delegate, which is func. Let's take a look at this one. The difference between func and action is func points to a method that returns a value, whereas action points to a method that returns void. So in this case, look, the first overload of func specifies out to result, and that is used to specify the return value from that method. If our method has 1 parameter and returns a value, we can use this overload. Or if our method has 2 parameters and returns value, we can use this one. So all these 16, 17, maybe 18 overloads gives you a lot of flexibility, which means you don't need to go and create your custom delegates. So let's change our application a little bit. I'm going to get rid of this photo filter handler and instead use the generic action delegate. So in the process method, we say you can pass any delegate that takes a photo as an argument and returns void. Let's run the application. We had an error here, which is saying the type name photo filter handler does not exist in the type delegates photo processor. So here, I forgot to change that. Here, instead of using the custom delegate, we use action of photo. Let's run the application. All good. So to recap, a delegate is a pointer to a function, or more accurately, it's an object that knows how to call a method or a group of methods. We use delegates to achieve flexibility and extensibility. Of course, we don't need this all the time, but if you're designing an application or a framework where extensibility or flexibility is a concern, we can use delegates for that. Alternatively, we can use interfaces. How do we decide whether we need to use an interface or a delegate to achieve flexibility? Well, part of that is personal preference, and different developers have different tastes. But the guideline in MSDN suggests to use delegates when we have some kind of eventing design pattern, or the caller doesn't need to access other properties, methods, or interfaces on the object implementing the method. In the case of the example I showed you, our filters were just one basic simple method, and there were no other properties or methods. But imagine if our photo processor needed to access other properties or methods. Obviously, a delegate wouldn't work, and we had to use an interface. Well, that's it for this video. I hope you enjoyed it, and thank you for watching. So, lambda expressions. What are these lambda expressions? A lambda expression is nothing but an anonymous method. That is a method that has no access modifier, like public or private. It has no name, and it has no return statement. Why do we use them? Why do we use anonymous methods? For convenience. We can write less code and achieve the same thing. Plus, our code would be more readable. Let me show you this with an example. Let's say we would like to write a method that takes a number and returns the square of that number. Typically, this is how we would do this. So, static int square int number return number times number. So return the square of that number. Let's make a call to this method. So first, I put console write line square, pass in 5 here. So we should get 25. Let's run the application with Control and F5. There you go. Now with lambda expression, we can achieve the same thing, but with less code. Let me show you how it works. The syntax for a lambda expression is something like this. So we have the arguments, then the lambda operator, and some expression. Read this as args goes to some expression here. For example, if I want to rewrite this method using a lambda expression, this is how I would do this. So the parameter or the argument is number, then goes to number times number. So this is what we call a lambda expression. And this code is exactly equivalent to this method. And as you see, it's shorter. I didn't have to specify static, an access modifier like public private, int as the return type or as the argument type. The compiler can automatically infer that in most cases. And if not, we can explicitly specify that. I also didn't have to write this return statement here. So what we need to do is we need to assign that to a delegate. Remember what a delegate is? A delegate is a pointer or reference to a method or a group of methods. In .NET, we have some built-in delegates that you see all the time. For example, we have func and action. Just to refresh your memory, let me comment out this bit. So func represents a method that takes 0 or more arguments and returns a value of type tResult, which is generic, as you can see here. Action, on the other side, is another delegate that takes 0 or more arguments and returns void. In this case, if you want to use a delegate to point to this method here, we need func. So we can say func of int and int. The first parameter here, the first generic parameter here, represents the argument to the method, and the second one represents the data type or the return value. So in this case, because our square method takes an integer and returns an integer, we use func of int and int. So let's give it a name. This delegate, as you see, can point to this method without any problems. Now, what I can do is, instead of creating that method here, I can just use a lambda expression here, saying number goes to number times number. And I can call this delegate like this. Let's run the application. We got the exact same result, 25. So there is no need to write this method here. I can just get rid of it. With ReSharper, as you see, it's grayed out. So I can press Alt and Enter. And note, the first suggestion is remove unused method. So enter, gone. So this is the basic syntax for a lambda expression. On the left side, we've got the arguments, the lambda operator, and the expression. If we don't need any arguments, we need to write a lambda expression like this. Goes to, and here's the code. If we have one argument, we can use just the argument by itself without using parentheses. And if we have multiple arguments, we should always surround them in parentheses. X, Y, and Z goes to blah, blah, blah. In terms of scope, the lambda expression here has access to all the arguments passed, as well as any variables defined inside the method here, where we define the lambda expression. So let me show you an example. Let me delete this. I will create another one. Let me define a constant, call it factor, give it value of 5. I want to create a method that takes a number and multiplies that by this factor. So I can use func delegate. The input to that function would be an integer, and it returns an integer. I call this function or delegate multiplier, and I use a lambda expression to say n goes to n times factor. So as you see, we have no compile time error here. This lambda expression perfectly understands this factor constant that is defined here inside this method, as well as the argument that is passed to it. So let me call this multiplier, give it a value of 10, so we should get 50 in result. And I can put that on console. So CW, remember, code snippet, tab, result, and let's run the application. There you go, we got 50. So this is the basic of Lambda expression. But let me show you a more practical and common use case of Lambda expressions. First, let me get rid of everything here. We're going to work on another example. Here, I've got a class called book repository. Let's say this is responsible for returning the list of books from the database. Now, to keep things simple here, I have just hard-coded a few book objects in a list. So this method here, getBooks, returns a list of books, and list, as you see, it's a generic type, as indicated by angle brackets. So it's a collection of books. And here I'm using the object initializer syntax during initialization of the list, so I can immediately populate that list with a few objects. As I instantiate each book, again, I'm using the object initializer syntax to quickly initialize the book object. So we have 3 books, title 1, 2, 3. The first 2 are less than $10, as you see, and the second one is $17. Let's say we want to write a code that returns all the books that are cheaper than $10. So let me show you how we would typically do this without a Lambda expression, and then we will refactor the code and use a Lambda expression instead. So first, let's get the list of books. So at this point, our books variable is of type list of book. So here, as you see in the tooltip, it points to a list of T, and here note that T is a lambda expressions.book. Lambda expressions is the name of my solution or project, so it's a namespace. Okay, now let's take a look at this object. See here in the list we have these find methods here that are used for filtering collections. I'm going to show you how to use find all. Take a look at the argument. Here we need a predicate of type book. What is a predicate? You see that all the time when working with collections. A predicate is basically a delegate which points to a method that gets a book, in this case, because it's of type book, and returns a Boolean value specifying if a given condition was satisfied. Let me show you an example. So I'm going to create a predicate function. Let's call it is cheaper than $10. I pass a book here, and I return true if book.price is less than $10. So this is what we call a predicate method. It gets an object of type book and returns true if a given condition is satisfied. All these find methods here they accept a predicate. Look. So what happens when I call this method and pass a delegate of type predicate, which means a method like this, I can pass that here, is cheaper than $10. What happens is the code inside this method will iterate the collection, and for each book, it will pass that book to this method to determine if the condition is satisfied. If yes, then it will return that book in the list of results. So with that code, I can say cheap books equals to that. And let's iterate that collection. It should be cheap books. And let's put that on the console. So I'm going to display the title of the book. Let's run this application. So we got title 1 and title 2. And back to our book repository. Note that both these are under $10. So the code is working. Now let's see how we can change this code and use a Lambda expression. See, the problem here is every time we want to call this find or any of its variations, we have to go and create a method like this. And while this is perfectly fine, we can achieve this with less code. So why not? So here, all we have to do is to say book goes to book.price is less than 10. So this lambda expression is exactly equivalent to this method here. And with ReSharper installed in my Visual Studio, you can see that now this method is grayed out, which means it's not used. So what I can do is to put my cursor on the method name here, and we get this triangle here. I can press Alt and Enter, and the first suggestion is to remove unused method. So I press Enter, and that code is gone. So again, this is a lambda expression. On the left, we've got the argument, and on the right side, we've got the actual expression. And this is what we call a lambda operator. We read this expression like this. Book goes to book.price is less than $10. In C#, it's pretty common to use a single letter when defining lambda expression arguments. So in this case, because we are working on books, it's obvious. So we can just use B. See, the code is even shorter now. Well, that's it for this video. I hope you enjoyed it, and thank you for watching. So what are events and why do we need them? Well, events is a mechanism for communication between objects. That means when something happens inside an object, it can notify other objects about that. Why do we need that? Because it can help building loosely coupled applications. What is loosely coupled applications? That means an application that its components or classes are not tightly coupled together. A loosely coupled application is easy to extend without breaking or changing one or more of its existing capabilities. Let me show you an example of this in the code. So take a look at this class. This is a video encoder class with one method called encode, which encodes the video that is passed to it. For simplicity, I've gotten rid of the encoding logic. But look at the last line. Here, when the encoding is finished, we use the mail service to send a mail message to the person that owns the video. Now, there is nothing wrong with this code, but let's say in the future, there is a scenario and we may want to send a text message to the video owner. So what we need to do is to go ahead and add this extra line of code to this method. Now, again, this is for simplicity. In a real world scenario, there could be a few more lines of code. Now, the problem here is because we add this extra line of code here, that encode method is changed, which means it has to be recompiled, which means the video encoder class also has to be recompiled, which means any other classes that are dependent on this video encoder have to be recompiled and redeployed. So as software engineers, we want to reduce this problem. We want to design our application such that when we want to change the application, that change has minimal impact on the overall application. The problem here with this code is that by adding that extra line, we may accidentally break something along the way. Now, we can use events to resolve this problem. Take a look at this picture here. We can have our video encoder class to publish an event called video encoded and have the mail service class to subscribe to that. In this case, we refer to video encoder as a publisher or an event sender, and mail service is a subscriber or an event receiver. Now, what is interesting about this picture? That video encoder knows absolutely nothing about mail service, which means in the future, if we want to extend our application and add the capability to send a text message when the video is encoded, we can simply create a new class called message service and have it subscribe to that video encoded event of the video encoder. So basically, the video encoder does not need to be recompiled and redeployed, and we simply extend the application by adding a new class. So this reduces the impact on the application. Ideally, if we could extend our applications by simply adding new classes, the compilation time would be reduced and application could be redeployed without breaking things along the way. Now let's take a look at what the code would look like if we want to implement this eventing mechanism between these classes. So here is our video encoder class again. We have the encode method as before with the encoding logic. At the end, instead of directly making a call to the mail service, which we had before, we simply call a method called onVideoEncoded. Don't worry about that method, I will cover it shortly, but the purpose of this method is to simply notify the subscribers. Video encoder knows absolutely nothing about the mail service or the message service. They can come later, and we can add more subscribers without changing anything in this code. Now back to our picture, you might be wondering, how does the video encoder notify these subscribers? Well, for video encoder to notify its subscribers, it needs to send a message to them. In practical C# terms, that means invoking a method in the subscriber. But how does the video encoder know what method to call? For that to happen, we need an agreement or a contract between these publishers and subscribers. So this agreement is something that both the publisher and subscriber agree upon. That is a method with a specific signature. Take a look at this method. So this method is void. It has two parameters, which the first one is an object and the second one is an event args. And this is a very typical implementation of a method in the subscriber. We often call these methods event handlers. And that's the method that is called by the publisher when the event is raised. So that means, back in our picture here, we need to have a method like that in mail service and message service. So when the video encoder wants to raise that event, it's going to call these methods. Now I need to clarify something here. Again, video encoder does not know about the existence of mail service or message service. It knows absolutely nothing about them. It's decoupled from them. All it knows is a method, nothing else. Now, how do we tell video encoder what method to call? That's when a delegate comes in. So a delegate is basically an agreement or a contract between publisher and subscriber. And it determines the signature of the event handler method in the subscriber. So back in our picture here, we can have a delegate that determines when a video is encoded and we want to notify subscribers, we should have a method that is void with these parameters. The name doesn't matter, but the signature is important. So now that you have a basic understanding of events and delegates, let's take a look at a piece of code and see how to create an event and a delegate. So here I've created a very simple console application. Let me walk you through the classes we've got here. First, we've got a video class, which is a very basic class with a simple property for the title of that video. We also have that video encoder that you saw earlier in the slides. So it has one encode method that gets the video. First, it logs a message on the console saying we are encoding the video. And just to simulate an encoding process, I used thread.sleep to delay the application for a period of 3 seconds. In the program CS, in the main method, first we instantiate the video here. Then we instantiate the video encoder. And finally, we call the encode method passing the video object. So very basic. Let me run the application now. So with Control and F5. Okay, we got the message encoding video, and notice there was a 3-second delay before we saw the press any key to continue. Let me run it again. So waiting, 1, 2, 3. There you go. Okay, now we want to implement an event in the video encoder such that when the encoding is finished, it notifies anyone who is interested in that event. Now, to give this class the ability to publish an event, there are 3 steps we need to follow. First, we need to define a delegate. That is the contract or the agreement between the publisher and the subscriber. So a delegate determines the signature of the method in the subscriber that will be called when the publisher, in this case video encoder, publishes an event. Second, we need to define an event based on that delegate. And third, we need to raise or publish the event. So let's go ahead and implement each of these steps here. To define or declare a delegate, we start with public because we want it to be accessible anywhere. Then we use the keyword delegate. Now imagine you're declaring a method. To declare a method, we need to specify the return type, give it a name and parameters. And this method would be actually the event handler in the subscribers. So if I want to declare an event, I would say void. I would give it a name, video encoded event handler. Then parameters, typically in .NET, we have this convention that we want the first parameter of the event handler to be an object. And that is the source of the event or the class that is publishing or sending the event. And the second parameter is an event args, which is basically any additional data we want to send with the event. So let's review up to this point. We are declaring a delegate, which actually holds a reference to a function that looks like this. So that function or method is void. It has two parameters. The first one, typically in .NET, should be of type object, which is the source of the event. And the second parameter is event args, which includes any additional data about the event. Now, how did they come up with this name? In .NET, we have this convention that we say if the name of our event is going to be video encoded, we use that and then append event handler as the name of the delegate. So that is our first step, define a delegate. Now we need to define an event based on that delegate. So we start with public event. This event should be based on that delegate. So we use video encoded event handler. Oops. Video encoded event handler and give it a name. So video encoded. Note that I use the past tense form here to indicate that something has happened and finished. Sometimes in .NET you may see an event referring to present tense, like saying video encoding. In that case, that event should be fired or published before the encoding is finished. Started. So here we just use the past tense. So the second step is done. We define an event called video encoded based on that delegate. And the third step is to raise the event. To raise an event, we need a method that is responsible for that. Let me create that here. So in .NET, again, there is a convention. .NET Framework suggests that your event publisher methods should be protected. They should be virtual and void. And in terms of naming, they should start with the word on and then the name of the event, which is video encoded. So here in our encode method, once the encoding is finished here, we just need to call this method. And we're assuming this method will notify all the subscribers. So how do we notify subscribers? That is the responsibility of this method. We start with checking if there are any subscribers to this event. So we say video encoded. If it's not null, now we need to treat this as a method call. That is, imagine you're making a method call here. So video encoded. To call methods, we use brackets. Now this method, look at the parameters, object source and event args. That's the signature that we defined earlier here, right? So what is the source of the event or who is publishing the event? The current class or the current object, which is this. And do we want to send any additional data with the event? I would say for now, just to keep things simple, I would say no. So whenever you don't want to send any additional data, you use eventargs.empty. This is a static property of this class, which returns an instance of eventargs, which is empty. Later, in the next step, I will show you how we can send the actual video that was encoded. So let's review the steps we have done. First, we defined a delegate, which is here, which determines the shape or the signature of the method in the subscriber. Then the second step was to create an event based on that delegate. So we define the event here. We are saying this event is called video encoded. And whenever we raise that, we want a subscriber with a method that confirms to this delegate would be called. And the third step is raising the event. So in our encode method, once we're done, we call this method, which by convention should start with the word on and then the name of the event. And it should be protected, virtual void on video encoded. Inside this method, we'll look at that event. And if there are any subscribers there, which means it shouldn't be null, we're going to call them, passing the reference to video encoder and no additional data. Now, we're done here. Let's go ahead and create a couple of subscribers. So I'm going to go to program here. Let me create a new class here. Mail service. So this class is responsible for sending an email once the video is encoded. Now I told you that back in our video encoder, when we define this delegate, I said we need a method that confirms with that signature in the subscribers. That method should be void and have these two parameters. So let's go ahead in our program CS here, in our mail service, create a method. This is the event handler. So that method should be void. We're going to call it on video encoded. It should have two parameters, object source, event args, E. Right? Now in this case, we don't want to send an actual mail. So I just want to simulate that. So we want to write a message to the console. I'll show you a quick tip here. Just type CW. That's a code snippet. If you press tab, that just writes console.writeLine. It's a way for you to quickly write code. I have a course on Udemy called Visual Studio Tips and Tricks, or Double Your Coding Speed. And in that course, I teach you a lot of code snippets and various techniques to help you write code faster. So in case you're interested, the link is on the screen here. All right, let's move on. So when this method is called, we want to log a message to the console saying, okay, we are in mail service, sending an email, That's pretty much it. Now, what we need to do is to subscribe this mail service to the video encoded event of video encoder. So here in the main method, we have the video encoder, which is the publisher. So that's going to be the publisher. Let me create an instance of mail service, and this is going to be my subscriber, right? Now, before we call the encode method, we need to do the subscription. How do we do that? It's very simple. So you start with the publisher, video encoder dot look at this icon. That's an event, video encoded. So we are interested in that. Now the notation is we use the plus equal operator. That is to register a handler for that event. Who's the handler? This method in the mail service. So I put that here, mail service dot, where is that? On video encoded and semicolon. Now note that I'm not making a call to this method here. So I don't have brackets here. I just use the name of the method. And basically what that means is this is a reference or a pointer to that method. So video encoded event behind the scene is a list of pointers to methods. When the video encoder wants to publish that event, video encoded, it looks at that list here. Here we look at that list. And if it's not empty, that means someone has subscribed to that event, which means we have a pointer to an event handler method. And then we're going to call that like this. That's just the syntax in C#. So let's get back to our program CS. So note that, again, we need to do the subscription before calling the encode method. Otherwise, the subscriber wouldn't be notified about the event. Now, let's run the application and see what happens. So we got the encoding video, which comes from the publisher, and then our mail service was notified and is trying to send an email. Now, let's look at some more interesting stuff here. First of all, I want to move this class to a separate file. The slow way of doing that is to go here, copy these, and then go to Solution Explorer, create a new file, and paste. It's not a good way. What is the faster way? There is a plugin called ReSharper, which is one of my absolute favorite plugins for Visual Studio. With ReSharper, you get this icon here. And see, it's suggesting to move this to another file. All you do is you put the cursor here on the class name, and then press Alt and Enter. And again, you get the suggestions here. Then press Enter. That's it. ReSharper moved that mail service class to a separate file, which is mail service, and added that to my solution here. So ReSharper really speeds up your coding. Again, I explained this stuff in my Visual Studio course on Udemy. So in case you're interested, have a look at that course and you're going to love it. Back in our program, now let's create a subscriber that is responsible for sending a text message. So I'm going to create another class saying message service. And again, we want an event handler method here. What is the signature of that method? Should be public void on video encoded. The first parameter should be object source, and the second should be event args. Again, we want to simulate a texting scenario. So just use CW, console.writeLine, press tab. There you go. So we are in message service now, sending a text message. And then I go here, Alt and Enter, move that class to a separate file. Now we can press Control and hyphen to get back to where we were, which is the program class. So similarly, with that publisher and this subscriber, now we can add a new subscriber. Var message service equals new message service. So here is another subscriber. By the way, this comments is purely for educational purpose. I'm not suggesting you to write comments like that in your production code. Okay, so we've got an instance of the message service. We need to subscribe to the event, just like before. So who's the publisher? The video encoder. What event are we interested in? Video encoded. How do we subscribe? Plus equal. Now message service dot on video encoded. And again, I'm not making a method call, so there are no brackets here, just a reference or pointer. Let's run the application again. Look, we got the encoding video message, which comes from the video encoder. Then mail service was notified. It's trying to send an email. And also message service was notified. And here it's trying to send a text message. Now, the beauty of this approach is when I created a new subscriber, which was message service, did I change anything in the video encoder? Let's go here. My video encoder is exactly the same. I didn't even make one line change. And that's what I was telling you in the slides earlier. So with events, you can create a publisher and you can add subscribers without changing the publisher. So this code doesn't need recompilation and doesn't need to be redeployed. And basically I can extend the application, add more capabilities by simply creating a new class, like in this case, message service. Tomorrow, we can have a new class, call it, I don't know, pager service, that sends a notification using a pager, and nothing else will be affected. Now, take a look at the video encoder here. Here we have a delegate, which actually is a reference to a method or the event handler. That method should be void and with these two parameters. Now we want to send a reference to the video so the subscriber knows which video we encoded. To do that, instead of using event args, we need a custom class. That custom class should derive from event args and include any additional data that we would like to send to our subscribers. So let's go ahead and create that. I go here. I call it video event args because it's a class that contains the data about the video that was encoded. So it should derive from event args. Here we need to create a property that determines the video that was encoded. So quick way of writing that is you type prop and then press tab. This is a code snippet. So now I specify the return type, which is video, and the name. I press tab again and enter. That's it. So now we can change our delegate here. Instead of sending event args, we send video event args. Which means here, see, we got an error because when we're publishing an event, we're sending event args.empty, whereas our delegate now expects a video event args object. So I'm going to go ahead and modify this. We need to instantiate a video event args. And we also need to send the video. Video equals, but where is the video? We don't have it here. But look, in the encode video, in the encode method, when we encode the video here, we have a reference to the video object. So we can simply pass that object to this method. And of course, we need to go ahead and change this. But with ReSharper, I can just press Alt and Enter. And see, ReSharper is suggesting to add that video parameter to this method. So I just go ahead and there you go. Now in the event publisher method, we've got a reference to the video and I can just put that here. So with this change, now our publisher is going to send some additional data, which is encapsulated in that class, video event args. And there we'll have a reference to the video that was encoded. Now let's go to mail service. We need to change this method to comply with that delegate. So instead of event args, we want video event args. All right. And then now what we can do here is we can just we can output the title of the video. So I would say we've got the video object here, the title. We need to make the same change in message service. Now a quick way to find that class instead of going in the tabs or in the solution explorer is just with ReSharper type Control T and then type message service. There you go. We are in that class now. So I'm going to go here and change this to video event args. And when outputting the message, I'm also going to add args.video.title. That's it. Let's compile and run the application with Control and F5. Okay, note that here, when mail service was notified, now we got the title of the video. So this is a way to pass data about the events that happened. Okay, the next step is to show you a simpler way to achieve the same thing with writing less code. So let's go to our video encoder, which is the publisher. See, we created this delegate here and specified these parameters as the arguments of the event handler method. Now, what they have done in .NET, I think it came with .NET Framework version 2.0 or 3.0. To make our life easier, they said, okay, we don't have to go and create a new delegate every time we want to declare an event. So in .NET, they have a delegate type, which is called event handler. And it comes in two forms. One is just a normal form and one is a generic form, which looks like this. What this means is they have done the hard work, so we can use that delegate instead of creating our own. Which means in this case, when we are declaring that event, instead of creating a custom delegate like that, we can just use the event handler delegate, not the icon here. I think it's suitcase. Looks like we're delegating it to, I don't know, what is it called in English? Solicitor, lawyer, I don't know. So that event handler type is generic, as you see here. Now, what do we want to send as additional data with the event? Video event args. Now that basically is exactly equivalent to this. So we don't have to create a delegate explicitly. We can just use this class here, which is a delegate. So I get rid of this. Now, if you wanted to publish an event without sending any additional data, instead of using the generic form like this, we could just use the normal form like this. Video encoded. Now, this is complaining because of the duplicate name. Let's just use video encoding. In that case, that means a method that gets object source as the first parameter and event args as the second parameter. Now, we don't really need it here. Okay, with that change, let's compile the application and run it. Everything working as before. Well, I hope at this point you have a good and in-depth understanding of events and delegates and how they help building loosely coupled applications. You saw how we can use events to make our applications extensible. And you also saw how to create a delegate and an event, as well as raising and subscribing to events. You also saw how we can use the event handler delegate that comes in the .NET framework, which saves us from creating our own delegate. So that delegate keyword that you saw earlier, I just wrote it because I wanted you to know what's exactly happening behind the scene. That came in the first version of .NET. But then this event handler class came, or delegate came, and we don't really need to create our own delegate. Honestly, I haven't seen a use case for that over the past, 12 years of me coding in .NET. Okay, that's it for this video. I hope you enjoyed this, and thank you for watching. Okay, extension methods. What are extension methods? Extension methods provide us the ability to add methods to an existing class without changing its source code or creating a new type that inherits from that. Let me show you an example here. Think of the string class. Let's say we have a string variable called post, which supposedly should contain a long blog post. So this is supposed to be a very long blog post, blah, blah, blah. Now, you have seen that in blogs, when you're looking at the index of the blog, you see the summary or shortened version of the blog post. So there are a number of words, and then there is ... at the end. You may want to implement something like that to shorten your strings. Well, unfortunately, we cannot change the string class because we don't have the source code, and we cannot inherit from string. Let me show you. So if I create a class here called public, say, public class rich string that derives from string, see, we get an error here. Cannot inherit from sealed class string. So in situations like that, we can use extension methods to add new methods to an existing class. So let me show you how we can create a method on the string that will look something like this. So I'm going to call it shorten, which gets a number of words. And then that would return, let's say, a shortened version of the post. To create an extension method, you need to create a static class. That's the convention that you need to follow. So we create a public class, public static class. A good naming convention is to start with the class you're extending, in this case string, and then add the postfix extensions. Now here you can write your extension methods. And you should start with public and static always. Now in this case, we want our shortened method to return a string. And here is the name of the method. The first argument of this method should always be this and the type you're extending and give it a name. So that's a convention you need to follow. And in this case, we want our shortened method to take a parameter of type integer called number of words. So with that method, as you see, now that shortened method is absolutely fine. I didn't have to inherit from the string class or change the string class's source code. Now let's go ahead and complete this here. But before doing so, I'm going to put this class in a separate file. Start with resharper, Alt and Enter. Oops. Not happy. I'm using a Mac keyboard here. Alt and Enter, move to a new file. So if the number of words is 0, we would return an empty string. Otherwise, we need to break up our string by the space character. So I would say str.split, space character here, and that would give me all the words in this string. Now, if there are less words than the number of words we have requested here, we just return the original string. But if there are more words, we need to get only the first few words based on the number of words here. So what we can do is we use the take method. Look, take here is an extension method. So if you look at words, the type of that is a string array. String array, which is an array, does not have a method called take. Later, Microsoft created an extension method called take that can be applied on any class that implements IEnumerable interface. In this case, the string array. So we use take method here, and I take this number of words, and I will join them with the space character and just return that. Now, to make my code a little bit more robust, if the consumer of this method sends a negative value as the number of words, that doesn't make sense. So I'm gonna do some defensive programmer here. Say if number of words is less than 0, throw new invalid argument. Throw new argument out of range exception. There you go. And we give it a message. Number of words should be 0 or should be greater than or equal to 0. Maybe even 0 shouldn't be a valid choice. Anyway, so let's review. We created a static class. We named it based on the class we're extending and the postfix extensions. All of our extension methods will end up here. In this case, we have only one extension method. They have to be public static, and their first argument should be this, the class we are extending, and give it a name. Now let's get back to our program. Now, because we are using that method on an instance of a string, when we go to the extension method, this first argument represents that actual instance that we are applying this method on. So let's verify that our code is working. So console write line, shortened post. Let's run the application. There you go. We only got 5 words. This is supposed to be, and we could actually make this method a little bit nicer and say, to indicate that there are more words, ... goes here. Let's run the application. This is supposed to be, so this is a good way of shortening strings. Now, a few things we need to cover here is, look at this namespace here, extension methods. This is the parent namespace for my application. So both this class and my program class are defined in extension methods namespace. But if I go and change this namespace here to something like extensions, what happens is if I go back to program, that method is not recognized. So that's a key thing you need to know about extension methods. They come to existence when the class that created them is in the scope. So in this case, I'm using resharper, and resharper automatically detected that that shorten method is defined in that class, string extensions, which is in the extensions namespace of extension methods namespace. So I can add that, we'll Alt and Enter. But the thing I don't like about this approach is if you are using a few extension methods here and there, you will end up getting a lot of namespaces like that on the top. So what I personally do is, because the string class is defined in the system namespace, and I'm extending that here, I would rather to use system here. This way, whenever I'm defining a string, I automatically have to import the system namespace, which gets that extension method as well. Another thing you need to know about extension methods is that even though you are applying them here on an instance of an object, they're essentially static methods. So as you can see here, there are static methods. But with this convention that we follow, we mark the class as static and the method as static, and this argument here, C# compiler allows us to use that method on an instance object. The difference is, if we use dot, note that, where is that? Dot shorten has a different icon from the normal methods, the normal instance methods defined in the string class. And that's the icon of the extension method. The other methods have this kind of purple cube, shorten. So the lesson is, these static methods can be troublesome at times. The problem is, let's say you extend the string class, but the creator of the string class, in this case Microsoft, ends up changing the class's implementation. And they may create a shorten method with exactly the same signature, but it may behave differently from your code. What happens is that the instance methods get priority over static methods, so your code will never be executed. So what Microsoft suggests in their guidelines is use extension methods only when you really have to. If you have the source code of the original class, go ahead and change it there. Otherwise, create a new type that derives from that class and add your new method there. And if that doesn't work, then go ahead and use extension method. In practical terms, in the real world, most often you will be using extension methods instead of creating them. A very good example of that is the IEnumerable interface here. Let me create an instance of IEnumerable of integers. Let's call it numbers, and I assign it to a list of integers. So list is an integer as a generic, so is the IEnumerable interface. Now, if I type numbers dot, look, these are the methods that are defined in the IEnumerable, like getEnumerator. But look, these are the extension methods. And here I'm using resharper, and resharper is great because it's telling me that this extension method is defined in this namespace, LINQ. So these are the extension methods that come with LINQ, which allow us to query objects. So as you see, there are quite a bunch of them here. Very, very useful. I'll cover them in a future video. So if I want to use, let's say, the max method here, resharper automatically added a reference to that namespace. So that extension method is now valid. Now, max method, what it does is it looks at that list and returns the biggest number. So let's initialize that list. Here I'm using the object initializer syntax. I can put numbers here immediately, 1, 5, 2, 3, 10 to 18. Now I can use the max method, and that returns the largest number. And I can put that on the console. Let's run the application. So 18 is the biggest number. So as you see, these extension methods are very useful, and most often you'll be using them as opposed to creating them. That's it for this video. I hope you enjoyed it, and thank you for watching. So we got to LINQ. What is this LINQ that everybody talks about? LINQ is one of my absolute features of C#. It stands for Language Integrated Query, and it gives the capability to query objects in C# natively. So with LINQ, you can query objects in memory like .NET collections, you can query databases, you can query XML, and you can query ADO.NET datasets. Querying .NET collections or objects in the memory is often referred to as LINQ to objects. Querying databases is often referred to as LINQ to entities. Querying XML is often referred to as LINQ to XML, and querying ADO.NET datasets is referred to as LINQ to datasets. Now, this is a comprehensive topic and is beyond the scope of this video. Especially LINQ to entities, which is used in Entity Framework, is a big topic, and it needs its own course. I'm actually planning on releasing a good comprehensive course on Entity Framework, so if you're interested, make sure to stay tuned. Now in this video, I'm going to show you the basics of LINQ and get you started. I'm going to cover a lot of ground, so you have a good understanding of LINQ and what problems it resolves. So let's jump into code. Here in this project, I've got a simple book class with two properties, string title and float price. I also have this book repository, which has one method called getBooks, which returns an IEnumerable of book. Basically, I have hard-coded a few book objects here in a list. So here I'm returning a new list. This is a generic list of books. I'm using the object initializer syntax here to immediately initialize this list. And then here I'm adding a new book, again using the object initializer syntax to immediately initialize the book. So as you see, our books here have title and a price. Let's look at our program CS. In the main method, we simply instantiate the book repository, call the getBooks method, and get the results. Now let's see what we can do with LINQ. Let's say we want to display the list of books that are cheaper than $10. If we didn't have LINQ, this is what we had to do. We would have to create a new list. We would have to iterate the books collection and then say if book.price is less than $10, add it to cheap books collection. And finally, at this point, we have the list of cheap books. So here we could iterate this collection and display each book title plus its price. So let's run this code. So these are the books that are cheaper than $10. Now, with LINQ, we can get rid of this piece of code here and do it with one line of code. So how? All we have to do is to say var cheap books equals books dot take a look at these methods here. These are extension methods, and you should be familiar with extension methods. So if you skip that video, make sure to watch it first. And here you see that these extension methods are defined in a namespace here, LINQ. So let me show you a method here where we use where to filter collections. Here I'm using resharper, and as soon as I use the where method here, resharper immediately added a reference to system.link for me. If you're not using resharper, you have to manually add a reference here. Now let's take a close look at the where method. The where method takes a func of book and bool. Remember func? It's a delegate. It points to a method that gets a book as an argument and returns a Boolean value. And this is what we call a predicate. So the job of predicate is to get a book, assess some condition, and if the condition is true, returns that book such that it will be added to the output. So whenever we see func as a delegate, we can use the lambda expression. Remember lambda expression? If you skip that video, make sure to watch it. So a lambda expression is a way to write an anonymous method, and that can be assigned to a delegate like func here. So here, I will write a lambda expression like b goes to b.price is less than $10. So just to refresh your memory, On the left side of the lambda operator, we have the argument, and on the right side, we have the actual expression. So this is like an anonymous method that gets B, which is a book, as an argument, and executes this condition here. Well, it's more accurate to say evaluates this condition. So if the condition is true, that book will be added to the list of filtered books, which will be cheap books. So with this line of code, we can easily get the list of books that are less than $10. Let's run the application. There you go. We got the same list of books. Now let me show you another method here. LINQ also has a method called order by, an order by descending, and this is used for sorting collections. This method gets an argument of type func of book and t-key, which is generic. So again, this is a delegate that takes a book, and then here we need to specify the property of the book on which we would like to sort the collection. So I can write a lambda expression here saying b.title. Let's sort them by title. Now what we can do here, which is extremely powerful, is we can chain these LINQ methods. So here I can put order by right after where. In this case, I am filtering the list of books here and then ordering them by title. Let's run the application again. Note that the list is now sorted by title. LINQ also has another powerful method, and it's called select. And select is used for projections or transformations. Let's say we want to iterate the list of books, and for each book we would like to convert it to another object. Or maybe we would just like to select one of its properties as a string. Let's say we get a book and select its title. So here, if we call this method, the result here, if we hover over var, look, the result is an IEnumerable of t, and t is a string. So with select here, we are converting a list of books which have been previously filtered and sorted. We're converting that to a list of strings because we are only selecting the title of the book. So now that we iterate this cheap books collection, we don't have this title and price properties anymore because book is now a string. So let me comment this out. Console write line, book. Let's run the application. So we just got the title of the books. Now in building real-world applications, sometimes the lambda expressions you write here get a little bit complex. So there is a common convention to lay out your LINQ methods here, and that is to lay them out like this. This way it's more readable and cleaner. So we filter, we sort, and select a property. Now this syntax is what we call LINQ extension methods. We also have another syntax to write LINQ queries, and that's what we call LINQ query operators. Query operators. I'm going to write the exact same code, but using a LINQ query operator. So I'm going to call this one cheaper books. This is how we write it. From B in books, where b.price is less than 10, order by b.title, and select b.title. So these two are exactly equivalent. LINQ query operators always start with the from and always finish with the select. So here from, you're seeing from B, that's like an argument in books. Now we filter by b.price, we order them by b.title, and then finally we select b.title. Or we could just return the actual book object. In this case, we'll get a list of books. If I hover my mouse here, you see we get an I-ordered enumerable of t element, and t element is LINQ.book. Which syntax you use, it's, I would say, purely personal choice. In terms of power and flexibility, this syntax is more powerful because internally, all these keywords translate to these extension methods here. And you'll find that in more complex scenarios, there are not keywords for every extension methods that you have here. But also in other scenarios, like when you are doing a group by or grouping lists, I think this syntax is more friendly and cleaner. So there is no right or wrong. It really depends on the situation and on your personal choice. Now for the rest of this video, I'm gonna just stick to LINQ extension methods and show you some really cool extension methods that make your life much easier. So I'm gonna get rid of this stuff here. And actually I will delete this here as well. We'll look at more examples in a second. So let's take a look at our list here. Here we have a book called ASP.NET MVC. Let's say we want to return only that book. Where method you have seen so far returns a list of books, an IEnumerable. But if you want only a single object in the result, that's when you use the single method. So single has pretty much the same argument as the where. It gets a function of book and bool, which is a delegate, and you can use a lambda expression here. So I would say, give me the book whose title is ASP.NET MVC. And I call it here book. Let's put that on the console, book.title. Let's run this. So here's our book. Now let's see what happens if I add something here. So obviously we don't have a book by that name. When I run this, the application crashed. We got an unhandled exception. Invalid operation exception. Sequence contains no matching element. This is one of the errors that you see a lot when working with LINQ. So, single method expects that there must be one and only one object in your collection that satisfies this condition. Now, if you're not sure if that object exists or not, you can use single or default. The difference is if there are no objects matching this condition, default will be returned, which in this case would be null. So my book object here will be null, and I cannot access the title property. Let me just show you that book is null is true. Let's run this. There you go. So book is null. We also have a few other similar methods to single. One of them is first. Now first is used to get the first object in a collection. Optionally, you can supply a predicate to filter. Say, give me the first book whose title is, let's say, C# Advanced Topics. Let's take a look at our book repository here. See, we have two books called C# Advanced Topics, and I want to get the first one. So I use the first method here. And here, let me uncomment this and also add the price of the book. Now let's run the application. So we got the book that is called C# Advanced Topics and it's $7. Let's look at our book repository. See, we have two books here and the first one is $7. Similarly, we also have a first or default, and this is similar to single or default. So if there are no books that match this condition, this method returns null instead of throwing an exception. We also have a method called last or default, and you should guess what they do. So let's try this one. Let's run this. So in this case, I got the book that is $9. Another useful LINQ extension method is skip and take. What are these? These are used for paging data. So with skip, you're saying skip 2 records or 2 objects and take 3. let's see if it actually works, because here I've got 1, 2, 3, 4, 5. That's fine. So it's going to skip the first two and return the next three. So let's run the application. Now this method returns an enumerable of book. So this should be books. Oops. And I would, the name is conflicting with this books here. So I'm going to call this paged books. And I would iterate the collection, paged books, and put the paged book title on the screen. Let's run this. So we got ASP.NET Web API as well as C# Advanced Topics. Let's double check. So we skipped 2 objects here and we got 3 objects. So skip and take are pretty useful. We also have a bunch of aggregate functions like we have in SQL. For example, let's say you would like to count the number of books. And of course, this is not going to be paged books, this is going to be count. And let's just put that on the console. So we have totally 5 books. We also have a useful method here called max, which is used to return an object that is assumed max of something in a collection. So in the list of books, what does max mean? We kind of have to give it a meaning. In this case, take a look at them. Arguments, we can pass a delegate that takes a book and returns some value here. So what I can do is say return a book that has the highest price. Let's run the application. That's $12. Well, count is not a good name. That max method is returning actually the price, the highest price, not the book that has the highest price. So that should be called maximum price. Similarly, we can have minimum price. Tell me how much is the cheapest book. Sorry, I forgot to put that on the console. So this one is going to be minimum price. So minimum price is $5. So max, min, count, and we also have sum. Let's say we would like to sum this collection based on the price of books. And we call this perhaps total prices, which actually doesn't make sense in this case, but I'm showing you as an example. So the sum is $42.99. So what I wanted you to learn in this video were these extension methods here. Books.where to filter and return a list of books that match a given condition. Or you can use single to return only a single book that matches a given condition. Or single or default, which is safer to use because single, if it cannot find any books that matches the given condition, it throws an exception, whereas single or default returns null. So these are for filtering. We also have first as well as first or default, which is safer. We also have last as well as last or default. We also have a bunch of aggregate functions like min, like max, like count, like sum. I think we even have average. There you go. So you can pass a delegate, say, give me the average of the price. We also have this useful methods here, skip and take, which is used for paging. Now, the beauty of LINQ is whether you're querying objects in the memory, or you're querying XML, or you're querying database, you keep using LINQ like this. You don't have to learn XQuery to query XML, or you don't have to learn transact SQL to query databases. Well, it's good to know SQL for programming databases, but in general, you can use LINQ in a lot of cases. And what LINQ does for you, or what Entity Framework does more precisely, is it takes this LINQ extension methods, and when you call them, it translates them to SQL query. So you never have to go and create a store procedure. Again, this is a very comprehensive topic and is beyond the scope of this video. Hopefully, I will release my Entity Framework course soon, and there I will explain all of these amazing things that you can do with LINQ. I hope this video gives you a good foundation to start with LINQ, see what benefits you get, and gets you prepared for real-world applications. I hope you enjoyed it, and thank you for watching. Okay, nullable types. What are they and why do we need them? In C#, as you probably know, a value type cannot have null. So if you define a bool, it can have either a true or a false. But there are situations that you would also like to cater for null values. For example, if you are working with a database and you have a table called customers, which has a column called birth date. Birth date can be nullable because not everyone wants to put in their birth date. In that case, if you want to map that table to a C# class, that's one of the cases where you use a nullable type. Let's see how nullable types work in action. So I define a datetime here, call it date, and set it to null. See, we immediately got an error. Why? Because datetime is a value type and as a result cannot be set to null. We can solve that issue by using nullable. Nullable is a generic structure that is defined in the system namespace. So with that, now we can have a variable that can have either null or a valid datetime. We can rewrite this code and make it a little bit shorter. The shorthand of defining nullables is to type the value type and then append a question mark. Now let's take a closer look at the members of a nullable type. Here are the properties and methods of the nullable type. GetValue or default, hasValue, and value are three members that you'll be using all the time. Let me show you the difference. It's best to show them by an example. So I'm going to put them on the console. Date, getValue or default. Date, hasValue, and date.value. Actually, I would like to add a label here. So getValue or default plus, and here I output hasValue. So it's clear what value each line is representing. Oops. And here that would be value. Let's run the application and see what happens. We got an exception. The application crashed. Let's take a closer look. So here, getValue or default returns a value if the object has been initialized with an actual value, or returns the default value for that data type if it's null. In this case, because we set our date to null, it's trying to return the default value for a datetime, which is day 1 of month 1 of year 1. If you define a nullable bool, this method would return false if you forget to initialize it. HasValue returns true if the object has a value, but if it's null, it returns false. In this case, because it's null, it's returning false. But look at the last one here. When we access the value property, we got an exception. And that exception is of type invalid operation exception. It's saying nullable object must have a value. So basically the lesson here is when you access the value property, you should make sure that your object has a value. Otherwise, you're going to get an exception. That's why we have this method here. So this is the preferred way of getting the value. This way, if the object has a value, you will get it. Otherwise, you'll get the default value for that value type instead of getting an exception. Now, let me show you something else about nullables. First, I clean up here. And I actually set the date value here. So new date time, let's say 2014, 1st of January. I define another date time. Let's call it date 2 and set this one here. See, we immediately got an error. Why? Because we are trying to put a nullable date time into a date time. and the compiler doesn't know how to respond to that? What if it's null? What should we do? The compiler doesn't know. So in situations like that, if you get that error, what you need to do is access that getValue_or_default method. In that case, because we have a value here, that will go straight into this date2. Let's verify that. There you go. All good. Now let's take a look at the other scenario. This time I define a nullable datetime and try to put date2 here. So in this case, you don't need to call this method or do any casting. A value type can easily be converted to a nullable type, as you see here. So let's display date3 getValue_or_default. There you go. Now let me introduce you to an operator that is pretty useful when writing code. It's called null coalescing operator. So basically, let me clean this up here and maybe just set this to null. Let's say we would like to write a code like this. If date is not null, set date2 to date. Otherwise, sorry, this has to be date.getValue_or_default because of the reason I just explained. Otherwise, if date is null, we would like to give date2 some default date. Let's say datetime.today. So in that case, because my date here is null, this else will be executed, in which case we set today's date here. Let's verify that. Date2. So today is 20th of November 2014. Okay, let's get rid of that. Now we can rewrite this block here much shorter. Let me show you how it works. So here I say date, null coalescing operator, which is double question mark, and then datetime.today. Basically how we read that is if date has a value, put it here. Otherwise, use this value. It's a little bit similar to the tertiary operator. Let me show you. You should have probably seen this. Datetime, date3 is if date is not null, use date, otherwise use datetime.today. Sorry, that should be that getValue_or_default because we are converting from a nullable datetime to a datetime. So this is the tertiary operator in case you haven't seen that before. So this is the condition, this is the if. If that is true, this will be executed until this colon. Otherwise, this will be executed. Now, null coalescing operator is even a shorter way of writing this code. So you put your variable on the left side. If it has a value, it goes here. Otherwise, if it's null, you use this value. Well, that's pretty much it about nullable types. I hope you enjoyed this video and thank you for watching. Okay, dynamics. Dynamics is one of the features of C# that sometimes confuses some developers, but it's actually pretty easy. Let me give you some background information. Programming languages are divided into two types: statically typed languages and dynamically typed languages. Or in short, we can say static languages or dynamic languages. Examples of static languages are C# and Java. Dynamic languages are like Ruby, JavaScript, Python, and so on. But what's the difference? The difference is in static languages, resolution of types, members, properties, methods is done at compile time. So if we try to access a method that is not defined in an object, when we compile the application, we are getting an immediate feedback that's telling us that method or property is not found on that object. With dynamic languages, the resolution of types, properties, members, methods is done at runtime. But what's the benefit of that? First, I'm not an expert in programming languages, but based on my understanding, dynamic languages are a little bit easier and faster to write code with. But on the flip side, because we lose compile time checking, we have to write more unit tests to make sure the application behaves properly at runtime. Now, C# started as a static language, but in .NET Framework version 4, they added dynamic capability to it. And the intention was to improve interoperability with COM or dynamic languages in .NET like Iron Python. If you're writing code for Microsoft Office applications such as Word or Excel, dynamic is a feature that is going to help you a lot. Without dynamics, you have to use reflection. What is reflection? Reflection is a way to inspect the metadata about a type and access properties and methods. Let me show you an example. Let's say I have an object here, give it a name of object and assign it to a string, my name. I can call the getHashCode method here like this, and that's pretty easy. But with reflection, if I want to call that method, my code will end up looking like this. First, I get the type of that object, and then I get a reference to a method called getHashCode, and that returns a method info object. Oops. Now I can invoke method info like this and pass some weird arguments here. As you see, this code is not very beautiful. So reflection is a little bit difficult and messy. The benefit of dynamic is that, let's say you're getting an Excel object and you know that that object should have some method called, I don't know, let's define an object here, Excel object. I set it to a string for now, just for simplicity, because I really don't have Excel objects here. But let's say, at runtime, that object should have a method called optimize, for example. You see that we get compile time error because the object class here does not have a method called optimized. With dynamic, we can easily resolve this problem without having to use reflection. With reflection, our code would end up like this, whereas with dynamic, it looks like this. It's much cleaner. So that's how you use dynamics in C#. But how does all that magic happen, as in resolving types, properties, members at runtime? You should be familiar with CLR, or Common Language Runtime. It's .NET's virtual machine that gets your compiled code, which is in intermediate language, which is IL, and then converts that or recompiles that into machine code at runtime. In .NET Framework version 4, they added a new component called DLR, which is Dynamic Language Runtime. So DLR sits on top of CLR and gives dynamic language capabilities to C#. Now, most often you're not going to work with that. It's just there. I'm just telling you that this is how the magic happens. Now, let's take a look at a few other things about dynamics. I can define a dynamic type here, give it a name here, and assign it to my name. And then in the next line, I can assign an integer to it. And that's perfectly fine. With static types like object, int, string, or whatever, this is not possible. We're going to get an exception. But if I run this code, the application runs successfully. There are no exceptions. Let's inspect this. I put a breakpoint here with F9. Run the application in debug mode with F5. Continue execution with F10. Let's put a watch on the name variable. Take a look here. So name is a dynamic and its runtime type is a string. But if I continue execution with F10, now its runtime type changes to integer. And that's one of the key differences between dynamic types and static types. With dynamic types, we can do whatever we want with them. And I think that's what makes them powerful in terms of writing code faster and easier. Now let me show you another example here. If I remove this line and instead try to apply a ++ operator to this name variable, let's see what happens. This time we got an exception. Unhandled exception is of type runtime binder exception, which is a popular exception when working with dynamic types. And the exception message says operator ++ cannot be applied to operand of type string. So At runtime, let me cancel that. So at runtime, the type of this name variable would be string. And of course, we cannot do that with a string. And that's the reason I told you with dynamic types, we need to write more unit tests to make sure application behaves properly at runtime. Let's take a look at another example. I'm defining a dynamic called A, set it to 10, then B set to 10, or let's say 5. This time I'm going to define a variable with var. Now, var is not dynamic. Var is basically a shorthand way of writing code and letting the compiler decide what type a given variable should be. So if I say var c equals string, empty string, then if I hover my mouse over var, then var is a string. It's a short way of writing code. I could just write string here, but var is a little bit shorter. Now, the interesting thing here is if I define C as A plus B, because A and B are dynamic, C will end up being dynamic. Look, that's dynamic. Let's put a breakpoint here. Run the application in debug mode. I'm gonna delete this watch here and put A, B, C here. So, continue execution with F10. So A is dynamic and its runtime type is integer. So is B. And so is C. So when you use dynamic variables in an expression, the expression will end up being dynamic as well. One more thing you need to know about dynamics is conversions or casts. Most often with dynamics, you get implicit conversion from and to the target type. So let me show you an example here. So I define an integer called I and set it to 5. Now I can define a dynamic called D and set it to I. In this case, I didn't have to specify a typecast or a conversion. At runtime, D will end up being an integer. Let's verify that. So continue execution with F10. I put D here in the watch window. So D is a dynamic and its runtime type is integer. Similarly, we can put dynamic on the right side of the assignment operator without the need to do any explicit casting. So if I define a long L here, I can put D inside long. At runtime, D will be an integer, and of course we can put an integer in a long variable without explicit casting. So the lesson is, when converting from dynamic to static types, if the runtime type of the dynamic object is implicitly convertible to the target type, you don't need to cast it. So let's verify this. So F10, F10, and I put a L here, and L, as you see, is long and its value is 5. And D is of course dynamic and its runtime type is integer. Well, that's it for this video. I hope you enjoyed it and thank you for watching. Okay, exception handling. In C#, we can use exception handling to deal with unexpected or exceptional situations that arise when a program is running. As .NET developers, we need to learn how to handle exceptions effectively. Let's get started with the code. Here we have a calculator class with a simple method called divide, which gets two arguments, a numerator and denominator. For simplicity, I have left out the other methods. In program CS, we simply instantiate that calculator and then call the divide method. We are sending 0 as the denominator. Let's run the application. The application crashed, and this is something that we need to avoid. Let me cancel this here. Take a look at the console here. It says unhandled exception, and that exception is of type system.divideByZero exception. Divide by zero exception is a class that resides in system namespace. So in .NET, an exception is essentially a class. And here is the message about that exception. Attempted to divide by 0. And the rest is what we call a stack trace. A stack trace shows the sequence of methods that were called until the exception was thrown. In this case, we got the exception at this divide method, which is defined in the calculator class in the exception handling namespace. And that happened in line 7. And before we called that method, we were here in program main method in line 9. So this is the stack trace, which shows the sequence of method calls in the reverse order. Let's close that. Now to handle exceptions, we use try catch blocks. Something like this. So we put the code that may throw an exception inside the try block. When an exception happens, the catch block is executed. If there are no exceptions, this piece of code will not be executed. So in this case, let me move these 2 lines here and a try. In the catch block, we usually have 2 choices. We can recover from the error and prevent the application from crashing, or we can what we call rethrow the error. That means send the error back to the caller of this code. In this case, because the main method is the starting point of the application, it doesn't make sense to rethrow the error. So what we're going to do here is just to display a user-friendly message to the user. Now, if I run the application again, see, this time the application didn't crash. We just got an error here. And this is better. It's not ideal, but it's better than an application that crashes. So as a guideline, you should always have a global exception handling block in your application. Now here we are using a console application, and each console application has a main method. That is the starting point of the application. And here is where we have our global exception handling block. If you're creating an ASP.NET application, you don't have a main method there. And there is a different way to implement something like that. I believe in Windows Presentation Foundation or WPF applications, we should have a similar main method. Honestly, I don't remember because I haven't done it for years. Now let's take a closer look at exceptions. Here in the catch block, we just have a type. And that exception is the parent of all exceptions in .NET. It's good to have an argument here so we can access the actual exception. Now I'm going to put a breakpoint here using F9 and run the application in the debug mode with F5. Let's take a look at the X argument here. Take a look at these properties here. Message is the error that is associated with the exception. Source is the name of the application that generated the error. Sometimes your application might have multiple assemblies or DLLs. So more accurately, source represents the DLL or the assembly that this exception happened in. Stack trace is what I told you earlier. It's a sequence of method calls in the reverse order. So if I click this magnifier icon here, let's take a look. So the exception happened at this line 7 of calculator.cs file, which was actually the divide method in the calculator class. And before we got to this method, we were here. Now, this is a very simple application. In real-world applications, you often see the stack trace includes quite a few number of method calls. Now, let's close that. Target site is the method where the exception happened. So these 4 properties are pretty common when working with exceptions. Inner exception represents an exception that could be inside this exception. I will talk about that a little bit later in this video. H result, to be honest, I have no idea what it means. I believe it comes from the world of Windows programming and it probably has a handle to the exception. I really don't know. Help link sometimes comes with some exceptions, and obviously that's a link where you can find more about the exception. In this case, nothing, it's null. And data, sometimes exceptions can carry more details with themselves, which is stored in data. Let's stop the debugger. When handling exceptions, you can have multiple catch blocks, and they have to be from most specific to most generic one. What do I mean by most specific or most generic? Well, If you remember, the actual exception that happened here was a divide by zero exception. Let's take a look at divide by zero exception class. So I type in divide by zero exception here and then press F12 to go to object browser. Look, here we've got divide by zero exception, and on this side, take a look, it derives from system.arithmeticException. So this is the parent. If I click this, it shows me that that class derives from system exception. And if I click this, it shows me that system exception derives from system.exception. So here we have a hierarchy of 4 levels of exceptions. The exception class is the parent of all of them, which is the most generic one. And divide by zero exception is the most specific one. So back here, let's say if our divide method could throw different kinds of exceptions and we wanted to handle each differently, we could have multiple catch exceptions here. So we start with the most specific, divide by zero exception. Then more generic one, which would be arithmetic exception. And the most generic one, which is the exception one. Why do they have to be from most specific to most generic? Because in C# or any object-oriented languages, you should know that this parent class can hold a pointer to any of its children, which means if we put this at the beginning here, any exception that happens, that catch block would immediately get that. So we won't have a chance to handle specific exceptions like this one here. And as you see, C# compiler is intelligent enough and is complaining about the order of catch blocks here. And that's why we get this red underline here. So I put this catch block back to where it was. Let's go ahead and write a different message here. So console.write line, you cannot divide by 0. Now if I run the application, this is the message we get. So this catch block was executed and it recovered from the exception. So these two were not executed. In C# we also have a finally block, which looks like this. Let me clean up some code here. Let's get rid of these. Okay. So why do we need finally block? In .NET, we have classes that access unmanaged resources. What do I mean by unmanaged resources? That is, resources that are not managed by CLR. So there is no garbage collection applied to them. Examples are file handles, database connections, network connections, graphic handles. And in situations like that, we need to manually do the cleanup. Now, any class that uses unmanaged resources is expected to implement an interface called iDisposable. Let me show you iDisposable here. iDisposable. So we press F12 to jump to object browser. Look, iDisposable is an interface and has a method called dispose, which is where we do the cleanup. And here the summary specifies, defines a method to release allocated resources. So we use the finally block to call the dispose method of the class that uses unmanaged resources. Let me show you an example. So I'm going to get rid of this calculator here. Let's define a stream reader. A stream reader is a class that is used for reading files. So I can say read a file located in C drive and is called file.zip. In the try block, I can read the content of this file. Say streamreader.read to end. And here in the finally block, what we need to do is call streamreader.dispose, which comes from iDisposable. So with this code, if anything goes wrong inside the try block during reading the file, we want to make sure that the stream would be closed. This is extremely important because if you don't manage these situations properly, you will end up keeping files open on the disk or keeping network connections open or your database connections, and sometimes you get out of resources. So make sure whenever you're using unmanaged resources, that is files, databases, network connections, graphic handles, make sure to dispose them here. Now, in terms of execution of this piece of code, first, this try block is executed. If there are no exceptions, this catch block will not be executed, but the finally block will always be executed. And if we happen to get an exception here, we'll just write this message to the console. And finally, we'll close the stream reader. Let me show you that in the debugger. So let's manually throw an exception here. We can throw an exception using the throw keyword. And just call it an exception. Oops. So I put a breakpoint here with F9 and run the application in the debug mode with F5. Well, interesting scenario. In fact, we got an exception right at the beginning here. This file actually did not exist on my local C drive. So in this case, note that we didn't actually write a proper exception handling code. So let's stop the debugger. This means if I run this application, it's going to blow up. We got an unhandled exception and the application crashed. So a better way was to actually write this here inside the try block. So if the file is not found, we make sure we catch the exception. The only problem is because I defined stream reader inside the try block, I cannot access it in the finally block. They have different scopes. So what we need to do is go ahead and say stream reader, and then assign it here. And of course, I have to initialize it to null here. Otherwise, I shouldn't call one of its methods. And notice here, I'm getting a warning saying possible null reference exception. And that happens if the stream reader is not initialized properly here. So the more reliable code is to say if stream reader is not null, then dispose it. Now let's remove this breakpoint here. So I press F9 again and put it here. Now I run the application in the debug mode with F5. With F10, I continue execution. So the control is here. I continue execution with F10. We display the message on the console. And note that the finally block always gets executed. In this case, stream reader is null, so it wasn't initialized and it won't be disposed. That's it. Now there is a cleaner way to write this code. We have a keyword in C# called using. So instead of declaring a variable outside the try block, then initializing it here, and finally checking if it's not null and disposing it, we can use the using statement. Let me show you how it works. So basically I come here, using var stream reader equals new stream reader. I get rid of this one here, and I don't need this. I need this, put that here, and we don't need this finally block. So basically, when you use the using statement, internally, the compiler will create a finally block under the hood, which will call the dispose method of stream reader. So you don't have to manually call that. Now inside the using, we can read the content of the file. And of course, this is our global exception handler, which should be here no matter whether we're using the using statement or not. So let's run the application again. Good. So the application didn't blow up. So the using statement is the preferred way as opposed to creating a finally block and calling the dispose method. So at this point, you should have an understanding of how to handle exceptions. You have seen the try block, you have seen the catch block, you have seen multiple occurrences of the catch blocks from the most specific to most generic ones, and you have also seen the finally block. But how can we create and throw custom exceptions? And in what scenarios do we need that? Take a look at this YouTube API class I have implemented here. Let's say you are creating a website, and as part of that, you need to get the videos for a given user and display them on a web page. So this YouTube API class encapsulates all that logic. It gets the username of the given user and returns a list of videos. So here the code would look something like this. Here we have a try catch block. Inside the try block, we access YouTube web service. We probably may have to open a network stream, read the data like as an XML, and then parse it, create a list of video objects, and let's not worry about that low-level complexity. But what matters here is there could be quite a few number of reasons where something could go wrong during fetching videos from YouTube. And often they would be very low-level exceptions like network stream, I don't know, parsing exception, whatever. You do not want to expose these lower level exceptions to the higher layers of your application. So in situations like that, you may want to create a custom exception called YouTube exception and handle it differently. For example, when recovering from that exception, instead, maybe you may want to display a list of default videos instead of YouTube videos. So let's go ahead and create a custom YouTube exception. First, I create a class here, public class, call it YouTube exception, and that should derive from system.exception. Now with ReSharper, I select this class, I put the cursor here, press Alt and Enter again, and it moves it to a separate file. Typically here, what we need to do is to create a constructor. So I type in ctor, that's a code snippet, press Tab, and got the constructor. And here we need to define two arguments, string message, and exception, inner exception. So with this constructor, then we can call the base constructor of the exception class and pass that message and the inner exception. That's all you have to do. Then in YouTube API class, let's say in the try block, something could go wrong here. They could be low-level exceptions. We can catch all of them here. Maybe we would like to log them somewhere. And finally, we would like to wrap them inside a more meaningful exception like YouTube exception. So here, as a message, I would say, could not fetch the videos from YouTube. So this exception is a lot more meaningful than, say, a low-level socket exception or parsing exception in the XML. And as a second argument, I can pass the actual exception, which will be wrapped inside this YouTube exception. Why do we do that? Usually for troubleshooting. So when we are troubleshooting the application, we look at YouTube exception and then look at the inner exception to see what is the actual problem that happened. So as you see, to throw an exception, we use the keyword throw and then new and the type of exception. Let's throw an exception here just to simulate how this would work. Oops, some low-level YouTube error. So in the try block, I'm manually throwing an exception to simulate a real-world scenario. Then I will catch that here. We don't have logging yet, but I'm going to encapsulate that actual exception here inside a more meaningful exception. Let's go to our program. And in the try block, let's create an instance of YouTube API and call the get videos method. And pass my name here. Sorry, var videos equal that. Now what we can do here is that exception would essentially be a YouTube exception. So if I display the message for that, let's see what happens. Run the application. Could not fetch the videos from YouTube. Let's run the debugger and see exactly what is happening. So I'm going to go to YouTube API, put a breakpoint here, run the application in debug mode, continue with F10. So we throw an exception and we catch it here. This exception is of type exception, system.exception. And the message is, oops, some low-level YouTube error. Now here, we are throwing a new YouTube exception, wrapping that low-level exception before. So, as we come out of that, we will get to the main global exception handling block inside our main method. If we look at that, X, let's continue execution by F10. Let's take a look. It says could not fetch the videos from YouTube because this is our custom exception. And if you look at the inner exception, it says, oops, some low-level YouTube error. So in the real world, when you use something like Entity Framework, which is used for accessing database, you're going to see that inner exception all the time. You get more generic exceptions, and then you keep looking at the inner exception to find the actual reason something went wrong. Well, that's it for this video. I hope you enjoyed it, and thank you for watching. Okay, we got to asynchronous programming. One of the things that confuses developers is asynchronous versus synchronous execution model. So in this lecture, I'm going to explain the difference between synchronous and asynchronous execution model, and then explain how we can do asynchronous programming with C#. In a synchronous program execution model, program is executed line by line, one at a time. When a function is called, program execution has to wait until the function returns before it continues execution to the next line. Let me show you a demonstration of that. Imagine here we have a piece of code with 4 lines. In the second line, we are making a call to a function that is going to be a blocking operation. It's going to be time consuming. An example of that is when we access a database or a website. So as we run this program, you see that each line is going to be green, and you will notice that in the second line, there is going to be a delay. Let's take a look. So here's a delay. So you notice that we blocked on the second line. Now, in asynchronous program execution, when a function is called, program execution continues to the next line without waiting for that function to complete. So let's do another simulation again. This time, you will notice that the second line executes immediately and the control will go to line 3 and 4. In the second line, we provide a callback to that time-consuming process function. So when the execution of that function is finished, then that callback function will be called. Let's take a look. So as you see, the program runs more smoothly. We didn't block on the second line. So what's the difference? Asynchronous programming model improves responsiveness of your application. You have already seen that in the real world. Think of Windows Media Player or your web browser. In the case of Windows Media Player, as it's playing a media, let's say a song or a movie, the UI continues to be responsive. You can resize the window, you can move it around, you can see an animation. If Windows Media Player did not utilize asynchronous programming, as it was accessing the file system and reading a piece of music, the window would freeze. You could not touch that window. Same for your web browser. As a web browser downloads content from the web, the UI is still functioning. It's responsive. And that's the benefit of asynchronous programming model. So when do we use asynchronous programming? Anytime we have a blocking operation, such as accessing the web, working with files and databases, working with images, and so on. Now, how do we do that? Well, traditionally in C#, we had two common approaches. One was using multi-threading, one was using callback methods. Both these approaches are complex to learn and understand. So in .NET version 4.5, Microsoft introduced a new asynchronous programming model, which is called task-based asynchronous model. And we achieved that by using async and await keywords. And that's the topic of this lecture. So let's jump into Visual Studio and learn about async and await. Okay, here I've got a basic WPF application with one form and a button here. And behind this form, we have a handler for clicking of that button. First, let's see how a synchronous operation can affect the responsiveness of our application. So I'm going to create a method here. Download HTML, that takes a URL. We're going to use a web client. And then get the HTML and that URL using download string method here. So download string takes a URL and returns a string, which in this case is an HTML. Now we need to write that HTML to a file on the disk. So let's use a stream writer for writing that HTML to disk. And I'm going to store it in a file here called result.html in my projects folder. It doesn't really matter. And here we use streamwriter.write to write that HTML to this file. Pretty simple, right? Now, in the button click, I'm going to call this method and pass an address like msdn.microsoft.com. Let's run this application. So when I click this button here, it's going to take a couple of seconds until we download that HTML. And during that time, this window is going to be unresponsive, which means if I try to drag and drop it, it's not going to happen. Or we cannot even resize or minimize this window. Let's see what happens. So click, look, it's not moving. Now it moved because the HTML was downloaded. Let's try again. Click. I cannot move this. Oh, there was a tiny delay here. So it depends on the operation. The longer the operation, the more unresponsive the UI is going to be. Now let's see how we can improve this by using an asynchronous operation. So I'm going to write an asynchronous version of this download HTML method. So let me scroll down a little bit so you can see easier. We start with public. All asynchronous methods should be decorated with the async keyword. So we put async here. Now for the return type, we need to return a task object. What is a task? A task is an object that encapsulates the state of an asynchronous operation. It comes in two forms. One is the non-generic form, which is this one here, and one is generic form. So if your method returns, let's say a string, you need to use the generic version of the task. So that would be task of string. If your method is void, you need to use the non-generic version of task, which is just this one here. So we return task here. Now we name our method download HTML. And by convention, we need to add the async suffix. You don't have to, but this is the recommended practice from Microsoft. And then we're going to use the same parameter here. Now let's copy paste this code inside our new method. Well, at this point, this method is still not asynchronous. All we have done is we changed the declaration of the method. But we are essentially calling a synchronous blocking operation here and here. So we need to change these two blocking operations to asynchronous ones. Now, since .NET 4.5, pretty much most methods that are blocking operations have an asynchronous or non-blocking version. And they all end with the async suffix. So let's have a look here. So in the web client class, we have download string, which is the synchronous version, and we have task async and async. This async method here is a legacy one, and it's got nothing to do with the new asynchronous programming model in .NET 4.5. So this is the one we're going to use. And as you see, it returns a task of string because the original method returned a string. Now the asynchronous version returns a task of string. So we're going to use this method here. And typically when we call an asynchronous method that returns a task, we need to put an await operator here. What does it mean? In the first glance, it may give you the impression that the program execution has to wait for this method to complete, but that's not the case at all. This is just a marker for the compiler. So when the compiler sees that, it knows that this operation is going to be costly and it may take a bit of time. In that case, instead of blocking this thread, it's going to return the control immediately to the caller of this method here. So the thread here is not going to be blocked and the control immediately returns here. And here we exit this button underline click method, which means the UI immediately becomes responsive. Now at some point, this method download the string task async is going to be completed. And the runtime is going to be aware of that because we marked this with await. So when this method is completed, runtime comes back here and executes the rest of this method. So the interesting thing here is if you compare these two methods, they look pretty much the same, except that in this method, we have an await here, whereas we don't have that here in the original synchronous version. But at runtime, how this code is executed looks different. It's like you have two different methods. One is one that includes only these two lines, and there is another method that is a callback once download string task async is completed. In that case, that method will be executed. We as programmers do not have to partition our code in terms of functions and their callbacks. And we are giving this hard task to the compiler by using the async and await keywords. Now, interestingly, this stream writer has a write method here, which is again a blocking operation. So we can improve the responsiveness of our application even further by using the asynchronous version of write method. So look, we have write async, write line, and write line async. So pretty much, as you see, for all synchronous methods, we have an asynchronous version. I'm going to use the async one. And as I explained, we need to put await here to let the compiler know that this method is going to take some time. So it returns the control immediately. And the executing thread is not going to be blocked. Now, in the button underline click, let me call the asynchronous version of this method and see how it makes a difference. So this time I'm going to click this button and note that the window is not going to be frozen and I can immediately move it around. So click, see, it's very responsive. One more time, it's responsive. Let's close this, get back to our original synchronous method. I click this button. It's not moving. It just moved now because the synchronous operation completed. So the use case for asynchronous programming is if you are building WPF applications or applications for the Windows runtime, wherever you have blocking operations like accessing files, accessing database, calling web services, or accessing web as you see here, accessing the calendar address book on a Windows mobile, all of these are blocking operations and you can improve the responsiveness of your application by using async and await. What about web applications like ASP.NET MVC applications? Well, in those applications, the UI is not in the same process. It's on the client's machine, in the browser. So does the new async programming model improve web applications? Yes. How? Well, typically in a web application, when a request comes to the server, a thread is allocated to handle that request. Now, During execution of that request, if there is a blocking operation, that thread is going to be busy. And each machine, as we know, has a limited number of threads. So if we have a lot of concurrent connections and all our threads are busy waiting for a blocking operation, that server becomes unresponsive. And the only way is to add more servers, which is scaling out. We can improve this by using an asynchronous model. So when a thread has to execute a blocking operation, the control immediately returns to the thread, and that thread can be used to handle another request. When that blocking operation completes execution, again, the same thread or another thread will come back here and pick up the rest of the program and continue execution. So with this model, we can scale up instead of scaling out. Now, that doesn't mean that if you design your application poorly, this is going to help you significantly. Not at all. But this is just a new practice and a recommended practice. So whenever you are using blocking operations, you should use async and await. Now, let's get back to our example here and see another use case. This time, I'm going to create a method that returns a string. So instead of being void, I want to return a string. So let's collapse these. Create a new method here. Get HTML from a URL. Similarly, we're going to use a web client and return web client.download string from that URL. So in the button underline click, I'm going to call this method, get the result, and display it. Sorry, I need to put the address here. Okay, now we got the HTML, and let's display it in a message box. Now that HTML is going to be huge, so I'm just going to get a substring of that. Let's say the first 10 characters. Let's run this application. So I click this button and notice there's going to be a delay until we get the result. And during that delay, the window is going to be unresponsive. So can't move. Now we got the message box. So here's the beginning of the HTML. I click that and now UI is responsive. Let's make this asynchronous and improve the responsiveness of our application. So we start with async. Instead of returning a string, we need to return a task of a string. So task of a string. Call it get HTML async. Takes a URL. I'm going to copy paste this code into here. Now this time, instead of calling download string, which is a blocking operation, I'm going to call download string task async. And as I said, this method returns a task of a string, as you see here. So we need to await that to tell the runtime not to wait for the result of this method and continue execution. Okay, now here in button underline click where we call get HTML, we're gonna replace this with get HTML async. Now the compiler is complaining. Why? Because this HTML is a task of a string. It's not the end result. It's a task object that represents the state of an asynchronous operation. So it doesn't have methods like substring. So we need to await that here to get the actual string. But interestingly, we got a red error here. Let's see what is here. It says the await operator can only be used in a method or lambda marked with the async modifier. What does it mean? Here we are awaiting for an asynchronous operation, but this method is not marked with async. So we need to change that to async, and now the error is gone. So the lesson is you can only use the await keyword or the await operator in an async method. Let's run the application. Click the button, window is responsive. Now we got a message. Let me show you something else here. We don't always have to await this asynchronous method straight away. Let's see what happens if we don't do that. So I'm going to remove this. And now this object is not the HTML, it's a task. So let's rename it to task of, let's call it get HTML task. And here I can say the actual HTML is await get HTML task. What does this mean? Well, when we call this method, the control immediately returns here. So we have a task object that represents the state of that asynchronous operation. Next, we come here and we are telling the runtime the rest of this method cannot be executed until this operation is completed. So the control immediately returns to the UI, and that's why the UI is responsive. But when that operation is completed, the rest of this code is going to be executed. At this point, we get the HTML and we display the message here. Now, what happens if we put a message box here? Let's say, waiting for the task to complete. Now with this code, as soon as we call this method, control comes here immediately. We get this message, and then UI becomes responsive. Once the HTML is downloaded, then we get another message. So let's run the application. Look, I click this button. We immediately got a message. Now the task completed and we got another message. So what I'm going to tell you here is you don't always have to await an asynchronous operation, and you can do instead some work in between that is not dependent on the result of that asynchronous operation. So this way you can utilize a thread to its fullest potential. You use await when the rest of that method cannot be executed until the result is ready. Well, that's pretty much it for this lecture. I hope you enjoyed and thank you for watching.